Okay, we will do an example that is very typical and that you need to understand how to solve very, not fast, but like easily, okay? So we have a pipe of steel, okay, that is thin, and inside we add some concrete. Let's do this one. So all the way inside it's concrete, okay? Here we go. And we apply a force that we know. Oh no, what's happened? Where's my concrete? Here we go. We apply a force on the top of 50 kilonewton, and we know the different dimensions. We know that the diameter outside here is 80 millimeter. We know that the thickness is 2.5 millimeter. We know that this one is steel, and I will give you the information that we have. And this one is concrete. Concrete. And the question is, what are the stress inside? Does that hold that weight? Um, oh, and we also know the length, but you know what? We don't even need it. Let's say it's 500 millimeter. We don't need it. It's very, you will see. Okay, so first thing, I will give you the E, the Young modulus E for the steel that we will use is 250 gigapascal, and the E for the concrete is 25 gigapascal, very less stiff. So how do we find those forces? What we know, like if we do a cut anywhere, like let's say we do a cut in the middle there, we know that the force in the concrete plus the force in the steel will be equal to 50 kilonewton. Okay, the 50 kilonewton is all the way on the area of both of them together, but the force inside both pipe will be different because they are not able to take the forces the same way. So this is equation number one. Equation number one, and we have two unknown. Equation number two, that will be the fact that the displacement of the concrete will be the same as the displacement of the steel. Okay, they move together, they will compress together, they will be the same. What is the formula for that? We will have the force on the concrete times L divided by the area for the concrete times E of the concrete equal the force in the steel times L divided by the area of the steel times the module Young of the steel. And we see we have on both sides, we have something that L is the same for both of them. So up, we can get rid of the L. Okay, I will write force in the concrete, and I will move that over there, and I will move that over there. Okay, so force in the concrete time the area for the steel time the module Young of the steel equal the force in the steel time the area for the concrete time the module Young of the concrete. Okay, so let's find all this information, and again in black that's our unknown. So the force of the concrete time the area of the steel, that will be pi time the diameter 80 divided by 2 square minus the inside, so the pi time 75 divided by 2 square time the E of the steel, that's 250 time at the 6, because it's gigapascal, it's equal to the force of the steel time the area of the concrete, that will be pi times 75 divided by 2, so the diameter of the concrete, and time square, don't forget the square, and time the module Young of the concrete, that is 25 times 10 at the 6, Okay, we have 10 at the 6 on both sides, so we can remove them. So we don't need them. And what I do, like with all of that, let me give you the value, but I love to do a matrix. Okay, so this one gives us F force in the concrete, and all of this, I don't think I used time the concrete. I think I have 152,170, 152,170, maybe with a 10 at the 6. And I have equal F of the steel time the force of the steel. I have 110,446,447. Okay, and what I do with that, I have this equation. Oh, this is my equation number 2. Okay, this is my equation. I may have kept the 10 at the 6. That's okay. Oops. I have this equation and these equations. Two unknown, two equations. I will add that in a matrix. So the first one will give us, okay, I will have the force of the concrete, force in the concrete first, concrete, and force in the steel second, and the equal. So my matrix for the force of the concrete, the first one is 1 plus 1 force of the steel equal 50. And the second one will be 152,170. Don't forget that I move that to the same side of the equal side, so to the left. So after that I have minus 110,447, and this is equal to 0. And I will do the first matrix, inverse, time the second matrix, and I will find the force of the concrete and the force in the steel. So force in the concrete with that will be 4.76 megapascal. And oh no, sorry, kilonewton. That's my I am one step after that. Force of the concrete will be 21.03. And 28.97 kilonewton. To get the sigma from that, let me move up, or maybe I can go under. Sigma in the concrete will be the force divided by the area, so that will be 21.03 divided by the area of the concrete. That was pi times 75 divided by 2 square, and I have sigma concrete 4.76 MPa, and sigma in the steel equal the force divided by the area of the steel. So this is 28.97 divided by pi times the 80 divided by 2 square minus the pi times the 75 divided by 2 square, because this is just the pipe, and we get 47.6 megapascal. Here we go. Sorry, I have to solve this one. This is funny. It's time 10, exactly time 10. And does that make sense? Yes, because the yield strength for the steel is way higher. So 47, oops. It's also way more expensive, the steel, than the concrete. So we prefer to fill the inside with concrete, right? It's not super strong, but we can put a lot, and that will spread all the forces on a larger area, and that will decrease um, the stresses inside. So very typical problems, okay? Two different materials, same length, like they are stuck together, so they move together, so their contractions, elongations is the same, but the forces inside and the stresses inside are not the same. Let me know if you have any question for this one. Bye-bye.